Respected professors, this is the video demonstration of the final DIY project of Team 16 consisting of Sneha Dash, Jagori Bandhopadhyay, Rohan Bogawat, Shri Srivastav and Saini Pooja.
So now let me take you through the components of the main system. So we have the Arduino board, then we have two gas sensors, the MQ135 gas sensor and MQ2 gas sensor. So the MQ2 detects the CO and LPG levels and MQ135 detects the CO2 level. Then we have a relay circuit. The relay circuit is basically used as an intermediate between the incoming input and the power output to the bulbs. Then we have a servo motor and the window hinge system. So this basically acts as a unit. So what it does is when the smoke level reaches severity, it opens the simple doors and windows in the room to reduce the smoke concentration in the room. Also for the same purpose, we have an exhaust fan, which is again used for the same purpose to direct the smoke out of the room to help in ventilation. And then we have a GSM module, which is basically used to call up a pre-saved number in case of an emergency. And we have the piezo buzzer. The piezo buzzer is basically used to alarm the victims just in case the victim is still in the state of taking an action. So he or she could be alarmed beforehand before any severe damages take place. So this is how the code has been done for a system. So firstly, we start here, and then the MQ2 sensor detects the CO, LPG, and smoke level, and MQ135 detects the CO2 levels, and then it feeds the data as input to our code. And then we have not provided any concrete limits for x1 and x2 over A for the sensor because these limits actually vary according to the temperature and humidity and other testing conditions. So we have provided a general limit in our code, but we have avoided that in the flowchart. So this can be used for any kind of condition. So if the value of MQ2 is less than x1 and MQ135 is less than x2, if this condition is true, then that means it's the ambient condition right now and the green light turns on and no other action is taken. But if this condition is not true, then it again tests the value against like two other limits, and then if it lies within this range, that is within the ambient air level and the hazardous level in between, then that means it is just crossed the threshold of ambient air condition, and in that case the yellow light turns on and a low pitched buzzer is sounded and an exhaust fan is turned down to return the condition to normalcy. If that is not the case and if it is in the hazardous region, then what happens is the servo motor and hinge system is activated and opens up the simple doors and windows in the room. The red light is turned on and a high-pitched buzzer is sound to alarm the victim. And also the GSM module is activated and sends a call to a pre-saved number to alarm any other person that the victim is in danger. So this is how the code works.
In this video demonstration, I first uploaded the code onto the Arduino board. Then I set all the connections and power supplies to start its functioning. As we can see, there is a source of smoke nearby which has just been lit. Now we are waiting for the smoke to rise and thus for the system to initiate. As can be seen, the green light glows when the density of smoke is very low. The GSM module is initiated and the message "project is ready to work" is sent. Now, when the smoke has become sufficiently dense to go beyond ambient levels, the yellow light glows and the alarming beep sound starts. The exhaust fan has started working to remove the smoke, and as the density varies, the light flickers between yellow and green. Now the levels of smoke have become critically high, turning the red light on. The servo motor has rotated 90 degrees and the associated hinge system has opened the window. Also, a smoke accumulation alert call has gone to the concerned number, informing them of the mishap, and a high-pitched buzzer alarming sound can be heard. Currently, we have set the delay to 20 seconds and it hangs up after that. It can be prolonged as required by changing the code. Now the smoke levels are changing and going low. Therefore, the window has closed and the yellow light starts glowing again. Smoke density lessens even more, making the green and yellow bulbs flicker, and eventually it stops on green. We have also taken into account the hazards caused due to degrading air quality, and therefore we have also built an air quality maintenance system which is going to be presented by Shrish.
Okay, so I would be explaining you the air purifier, and let me run you through the components of it. This is a DC socket, this is an SPST switch, and this is a 12 volt an air blower GPZ A12 type, and this was a carbon filter sheet, and I have made it into 4 layers. And for the power supply, I'm using an AC/DC converter 12 volt 1 ampere adapter, and I would be connecting this to the DC socket. And let me turn on the switch. So you can see the motor is working fine. Okay, so if I explain you the structure of this air purifier, I have created and cut out here, which leads to the filter. And this blower, what it does is it create a suction over here, so the impure air or whatever the foul air gets sucked into it, and it passes through the filter eventually and gets purified. And what this does is it expels the purified air from this. I have created a kind of ventilation here so that the purified air can be expelled out. Okay, you can see that I have fixed the motor using 2 nut bolts. To explain the working of a air purifier, I would be using an incense stick. So you can see that the smoke of the incense stick gets sucked into the air purifier, it passes through the filter, the blower circulates it and expels the purified air out of the ventilation which has been created on the side of the box.
We hope we were clearly able to explain the working of each and every component of this project. Its report, its record and presentation has been made possible by the efforts of all these people. Hope you like the project and its presentation.